ఫిజిక్స్లో రిఫ్లెక్షన్ ఆఫ్ లైట్ గురించి డిస్కస్ చేద్దాం. ముందుగా మనకి రిఫ్లెక్షన్ ఆఫ్ లైట్లో మెయిన్ ఇంపార్టెంట్గా తెలుసుకోవాల్సింది లైట్, దాని యొక్క ప్రాపర్టీస్. ముఖ్యంగా మనం లైట్ యొక్క ప్రాపర్టీస్లో మెయిన్గా గుర్తుంచుకోవాల్సింది రెక్టిలీనియర్ ప్రాపగేషన్ ఆఫ్ లైట్. ఓకే, రెక్టిలీనియర్ ప్రాపగేషన్ ఆఫ్ లైట్. రెక్టిలీనియర్ ప్రాపగేషన్ ఆఫ్ లైట్ అంటే లైట్ ఆల్వేస్ chooses a path. Okay, when it is going from one point to another point, it always chooses a path which is taking least time for that, so that we can cover the distance very early here. So that, for suppose, if light is going from point A to point B, so that it is taking a path such a way that we can cover the distance from A to B in very less time. It is possible only if you are going in a straight line. This is what given in the rectilinear propagation of light, which is given by Fermat. His name is Fermat. This is called Fermat's principle. Now we will see about the reflection of light. Okay, reflection of light. Reflection of light is nothing but if you are taking any light ray which incident on a surface, make sure that that surface is a opaque surface. It need not to be plane surface, any surface you can take. If the light ray incident on the surface, and that too the light ray which is incidenting on the surface, this one we call that as incident light ray or simply incident ray. When that incident ray strikes the surface which is an opaque surface, what happens there is the light ray bounce back into the same medium, and the light ray which bounce back into the same medium, we call that as reflected ray. We call this as reflected ray. Okay, so reflection of light is nothing but when a light ray incident on a surface which is a opaque surface, what happens there is a bouncing back of light ray into the same medium, and that light ray which bounce back, we call that as reflected ray. See that again, reflection of light phenomenon here. Okay, when a light ray incident on a surface which is a opaque surface we are taking, then what happens there is that incident light ray bounce back into the same medium. This phenomenon only we call that as reflection of light. And the point where the light ray incident on the surface, that point we call that as point of incidence, O that is. Okay, and if you are taking a line which is taken perpendicular to the surface, okay, the line which is taken perpendicular to the surface, that line we call that as normal. Okay, now this incident ray is making an angle with this normal, that only we call that as angle of incidence, and the reflected ray which is making an angle with the normal, that only we call that as reflected angle or angle of reflection, which is represented with R. Now see here, as the light ray is started in a medium, as it is bouncing back into the same medium, so there is no change in the medium, so that the velocity of the light remains same. This one you have to remember, which is very very important one. As the light ray is not changing its medium, as it is continuing in the same medium after bouncing back also, that's why the velocity of the light remains same. Now we will see the laws of reflection here. Okay, now for laws of reflection we are having total 2 are there. Okay, first law is, according to this first law, this incident ray, the normal and the reflected ray, all these three lie on a same plane. Okay, see that again, the incident ray, the normal and the reflected ray, all the three lines should lie on the same plane. Okay, and the next one is very very important one, which gives you the relation between the angles of incidence and reflection. According to this second law of reflection, the angle of incidence made by the incident ray with the normal is equal to the angle of reflection made by the reflected ray with the normal. So means angle of incidence equal to angle of reflection. Now we will see a very important one about the relation between the angles. Okay? If you are taking about the relation between the angles, we already know that the incident ray is making an angle with the normal. We call that as angle of incidence, and angle made by the reflected ray with the normal, we call that as angle of reflection. At the same time, this incident ray is also making an angle with the surface, with the reflecting surface, that you call that as glancing angle of incidence, glancing angle. Now, and the reflected ray is also making an angle with the surface. This we call that as glancing angle of reflection, that is called as glancing angle of reflection. So that if you observe this glancing angle of incidence and angle of incidence, if you are taking along with the normal, this total is nothing but equal to 90 degrees, that is, which means the glancing angle of incidence plus angle of incidence is equal to 90 degrees, because normal is nothing but a line which is making an angle perpendicular to the surface. As it is perpendicular, this total angle of glancing angle of incidence, that sum it is equal to 90 degrees, that is. Then from this, glancing angle of incidence is equal to 90 minus I, that is. Okay, that is our glancing angle. Now, in the same way, if you are taking about the reflected ray, again angle of reflection, glancing angle of reflection, GR plus GI, that is of R, is equal to 90 degrees. Then from this, glancing angle of reflection is equal to 90 minus R. And we know that according to the laws of reflection, second law of reflection, angle of incidence is equal to angle of reflection, that is. Then if we know that as I is equal to R, if you substitute that in GR, then GR is equal to 90 minus I, that is. Okay, but 90 minus I is nothing but equal to GI. Then glancing angle of reflection is equal to glancing angle of incidence. Okay, now we got mainly three relations here. As we already know about angle of incidence equal to angle of reflection, this is one. And second one, glancing angle of incidence is equal to 90 minus angle of incidence, glancing angle of reflection is equal to 90 minus angle of reflection. And not only that, we got that glancing angle of reflection equal to glancing angle of incidence. Now we will see another important angle, which is called angle of deviation. Angle of deviation is nothing but how much the light ray is deviating from its original path. That only we call that as angle of deviation, that is. Then according to this angle of deviation, how to take that is the angle made by the extended incident ray, which is the original path of the light ray. This extended incident ray making angle with the reflected ray. This angle we call that as angle of deviation, D, that is. The angle made by the extended incident ray with the reflected ray, that only we call that as angle of deviation, that is. Then how to get this angle of deviation is, if you are taking this extended incident ray, this total angle becomes 180 degrees, that is. In this 180 degrees angle, we are having angle of incidence is there, angle of reflection is there, glancing angle of reflection is there, and at the same time this extra angle also we have. Okay, and that angle is nothing but equal to the glancing angle of incidence, this one. Okay, that total we got that as 180 degrees, that is. Now we will see as that 180 degrees is equal to, in that 180 degrees we are having angle of incidence, angle of reflection plus this angle which is GR and GI, that is equal to angle of deviation, that is D. And we know that angle of incidence is equal to angle of reflection, that is. Then 180 degrees is equal to I, angle of reflection is also I plus angle of deviation D, that is. Then 180 degrees is equal to 2I plus angle of deviation D. Then angle of deviation becomes 180 minus 2i. This is the relation. Okay. So, finally, we got angle of deviation is equal to 180 minus 2i, that is. Till now, we have seen that about the reflection of light and some of the basic important angles we seen. Now, we are seeing very important one, that is about the image formed by the plane mirror here. Okay. Image formed by the plane mirror. At first, this image, here we are having total two types of images are there. One is a real image and another one is virtual image. Virtual image, which is not a real image. Real image and virtual image, that is. Real image, when we can say that is, after the reflection phenomenon is over, after reflection, if the light rays are really meeting at a point, then we can say there is a formation of real image. Whereas virtual image is when the light rays after reflection, if they not meeting at a point which are appears to meet at a point, that only we call that as virtual image, that is. See that again, very important one. Formation of real image means after reflection from a surface, if the light rays really meeting at a point, then we can say that is called as a real image. And virtual image is nothing but after reflection from a surface, if the light rays or appears to meet at a point, that we call that as virtual image. Okay. Whereas virtual image is not a real image, because the light rays are appears to meet at a point, they are not really meeting at a point. Okay. That is why it is called as virtual, not a real image. Now, we will see the image formed by plane mirror. Okay. But remember, plane mirror reflections, okay, after reflection the light ray is bouncing back into the same medium here. Okay. Now, here we are taking as the image formed by plane mirror, for the case of a point object we are taking that, which means if you are taking a point object which is very less in the dimensions, so that we are placing that object before the mirror. Okay. We are placing a point object before the plane mirror. As it is of a plane mirror, here what happens there is the light rays which are started from the point O, which is our object, incident on the plane mirror, and the light rays reflect from the surface. And we know that the angle made by the incident ray is equal to angle made by the reflected ray. So that what happens there is, after reflection from the plane mirror surface, the light rays diverge away from each other. As the light rays are diverging away from each other, they never meet at a point. So that is why here the light rays are appears to meet at a point, that too which is behind the mirror. Okay. The light rays appears to meet behind the mirror. As the light rays are appears to meet behind the mirror, this formation of image we call that as virtual image. So the image formed by the plane mirror is a virtual image. Here very important thing to see here is the distance where we are placing the object before the mirror. Here this distance, let it be that is x. The distance where we are placing the object from the mirror, we call that as object distance. In case of plane mirror, the image is also formed behind the mirror at the same distance, which means both are equal to x and x. So in case of these plane mirror images, not only angle of incidence is equal to angle of reflection, even the object distance is also equal to image distance. But as the image formed is a virtual image, that image is forming behind the mirror. Okay. This is about the point object image formed by plane mirror. Just like the point object we explained, now we are seeing this is called extended object. Whereas point object means we don't have a particular dimension for that, very small dimensions, that is like a point. Whereas in case of this extended object, we are having some length is present, we are having height is present for the object. In case of this also, when you are taking any of the point here which is started from the object, for example here if O is the object, here I am taking the light rays. So that here the light rays which reflect from the plane mirror, again they are going like a divergent beam of light rays here. So again, as the light rays are not really meeting at a point, they are going to meet at a point which is behind the mirror. Again we are forming a virtual image. So it is very clear that the image formed by the plane mirror is always a virtual image. And not only that, the angle of incidence is equal to angle of reflection, which means the angle of the distance here made of which we are taking the object from the mirror is equal to the distance where the image is forming, which means object distance is equal to image distance. In case of point object you can take, or in case of extended object you can take. In both the cases, object distance is equal to image distance, and not only that, if you observe, both the object and image both are forming in the same line. Now we will see for our competitive exam, which is a very, very important topic about spherical mirrors. Okay? Spherical mirrors. The term itself, spherical, means which is taken from sphere. Okay? Which is taken from a sphere. Actually, spherical mirrors are nothing but, if you are taking a hollow sphere, a glass sphere, a hollow glass sphere. Now, these spherical mirrors are nothing but, if you are taking that hollow sphere, a small piece or a part, when you cut a small piece from this sphere, now we are getting a curved surface like this. To this curved surface, if you silvered any one of the surface, you can take the outer surface or you can take inner surface, any of the surface, like this. This is called silvered surface. Silvered surface means where there is no reflection takes place. And why to silver? That is, here if you make this as a silvered surface, so that no light rays will pass through that one, because we need the reflection phenomenon, that is. Okay? If you are making that outer surface as a silver surface, then this one we call that as concave mirror. It is called as concave mirror. And the surface of which, if you are making the silvered surface, inner surface, then this is called as convex mirror. This is called as convex mirror. So mainly we are having in spherical mirrors, two are there. One is a concave mirror, another one is a convex mirror. Whereas concave mirror is such a way that it is the outer surface is silvered, only the inner surface is acting like a reflecting surface. So the surface where the reflecting surface is inwards, that we call that as concave mirror. And for the case of convex mirror, the outer surface is the reflecting surface. This is the reflecting surface. Okay? These are concave and convex mirrors. Now we will see some of the important basic definitions required for our spherical mirror. Okay? You can take a concave mirror or you can take a convex mirror. For both of them it is same only. Okay? Very, very important one, first basic one is about the center of the mirror, which is about our concave mirror here in this case. The geometrical center of this concave mirror, this point, we call that as pole. It is called pole of the spherical mirror, pole, P. Okay? See that again, pole. Pole of the spherical mirror, which is nothing but the geometric center of the given spherical mirror. You can take a concave mirror or you can take a convex mirror, any of the mirror. The geometrical center of that mirror, we call that as pole. Okay? Next one, second important one, which is the center of curvature. Center of curvature, represent with C. Now, center of curvature is nothing but, as all our spherical mirrors are, they are taken from a sphere, that imaginary sphere if you are taking, where our concave mirror or a spherical mirror is a part of that. Okay? The center of that imaginary sphere, the center of this imaginary sphere, that we call that as center of curvature. See that again, the center of imaginary sphere of which our spherical mirror, here it is a concave mirror, is a part of it, that we call that as center of curvature. That is the second one. And third one, we call that as principal axis. Remember, principal. Principal means head of all the axis. Principal axis. Now see, principal axis is nothing but an imaginary line passing through the center of curvature as well as the pole of the spherical mirror. An imaginary line passing through center of curvature and the pole of the spherical mirror. This we call that as principal axis. Okay. Next one, radius of curvature. Radius of curvature. This represent with capital R. Okay. Radius of curvature is like our radius for a circle. As here we are talking about the sphere. Now radius of curvature is nothing but here the distance between the pole and the center of curvature. This distance we call that as radius of curvature, R, that is capital R. Okay. The distance between the pole and the center of curvature of this spherical mirror, that we call that as radius of curvature, that is. Now again we will see these definitions. Okay. First one is pole. As I said, pole is nothing but the geometric center of the given spherical mirror. It may be a convex or it may be a concave. The geometrical center of the spherical mirror, that we call that as pole. And next one, center of curvature. As our spherical mirror is a part of a glass sphere, that glass sphere we are having a center. That imaginary glass sphere center only we call that as center of curvature. Okay. And next one is the principal axis. Principal means head. Okay. When you are taking a imaginary line, an imaginary line passing through center of curvature and the pole, we call that as a principal axis. Okay. And next one is radius of curvature. Radius of curvature is nothing but the distance between the pole, which is actually on the circumference of this circle here. Okay. If you imagine that sphere is like a circle. Okay. From the point P, which is the pole, up to the center, that distance only we call that as radius of curvature, just like our radius in circle. Now we will see another next important definition, principal focus. Previous one is principal axis, now this is a principal focus. Okay. Now principal focus means if you are taking a parallel beam of light rays, if you are taking a parallel beam of light rays, when the incident on this spherical mirror, for suppose if you are taking a concave mirror, if the light rays incident on this concave mirror, after reflection the light rays are passing through a point. That point here we call that as focus. If that focus, if it is forming on the principal axis, then we can say that is called as principal focus, that is. Okay. See that again, very important. When you are taking a parallel beam of light rays, when incident on a spherical mirror like a concave mirror, after reflection the light rays are going to meet at a point. And if that point, if it is forming on the principal axis, then we can say that is called as a principal focus. Actually, if you are taking these parallel beam of light rays parallel to our principal axis for the spherical mirror, always the focus is formed on the principal axis only. Okay. And in the same way, even for the case of convex mirror also, if you are taking a parallel beam of light rays, when incident on this convex mirror, after reflection, actually the light rays are diverging away from the mirror here, because that convex mirror nature is a diverging nature. So that's why after reflection the light rays are moving away from each other, they diverge from each other, so that here the light rays are appears to meet at a point, which means those light rays are appears to be coming from a point. That point we call that as focus here, which is clear that concave mirror is having a real focus, whereas convex mirror it is having a virtual focus is present. that point only we call that as principal focus. Okay, this is for concave mirror and this is for convex mirror, that is. Okay, next one, here after that principal focus we are having focal length is present. Next one is focal length f. Okay, focal length, the term itself length. Length is nothing but the distance here. Focal length is nothing but the distance between the pole and the principal focus. The distance between pole and the principal focus, we call that as focal length, this distance. Here for convex mirror, this distance. Okay, the distance between the pole and the principal focus, that only we call that as focal length, that is. Now we will see the rules for drawing ray diagrams here. See, ray diagram is nothing but the diagram which gives you the formation of image formed by a mirror, that only we call that as ray diagram. Now we are seeing the rules for drawing those ray diagrams here. Okay, the first one is, if you are taking any of the mirrors, spherical mirror, concave mirror or for convex mirror, concave mirror or convex mirror here, if you are taking a parallel beam of light rays, okay, any light ray which is passing parallel to the principal axis, after reflecting from the spherical mirror, the light ray passes through principal focus. Okay, see that again, any light ray which is taken parallel to the principal axis, after reflection the light ray passes through principal focus. This is our rule 1. But here in case of convex mirror, as we are not having a real focus is present, then what happens there is, after reflection, when you are taking a parallel beam, which means a parallel light ray passing parallel to the principal axis, after reflection the light ray appears to be passing through principal focus. That only our rule 1. When it comes to rule 2, second one. Now rule 2 is exactly opposite to this rule 1, which means now we are taking a light ray to this concave mirror, for example. Okay, to this concave mirror, now I am taking the light ray which is passing through focus. If you observe here, first case we are taking a parallel light ray parallel to principal axis, so that it passes through principal focus. Now just exactly opposite to that, now I am taking the light ray passing through focus. Okay, now when it incident on the surface, after reflection, now the light ray passes parallel to the principal axis, like this, exactly opposite. Okay, see that again, the light ray, if it is passing through the focus or appears to be passing through the focus, after reflection the light rays are going parallel to the principal axis. Not only for this concave mirror, even for the case of convex mirror also same. Okay, now we are taking, as it is having a virtual focus is present, now we are taking the light rays or appears to be passing through the focus, like this. Means the light ray is going towards the focus here. After reflection from the convex mirror, now the light ray is passing parallel to the principal axis, like this. This is our rule 2. Now we will see rule 3. According to this rule 3, any light ray which is passing through center of curvature of the spherical mirror, let us suppose a light ray passing through center of curvature of our given spherical mirror, concave mirror. Then after reflection, what happens there is, the light ray is retraced back in the same path. Now the light ray is coming back in the same path here. Okay, not only for this, even for convex also same. Here, as the focus and the center of curvature is behind the lens, behind the mirror we have, then we are assuming that the light ray is passing through the center of curvature here, like this. Then after reflection, now the light ray is coming back in the same path. This is our rule 3. Okay, but if you observe that, if you are taking that angle, the light ray is coming back in the same path, which means here the angle of incidence and the angle of reflections, if you observe, okay, the angle between them becomes 180 degrees here, because the light ray is retracing back here. Okay, and next one, rule 4, that is of, if you are taking any of the spherical mirror, if the light ray incident on the pole, which is our geometric center of the spherical mirror, after reflection, what happens there is, their angle of incidence and angle of reflection both getting equal, which means we are getting a regular reflection here. Okay, so when the light ray incident on the pole of the spherical mirror, after reflection, the light ray passes with angle of incidence is equal to angle of reflection, that is. And even for convex mirror also it is the same. Okay, like this. Here again, angle of incidence, angle of reflection, both are same when the light ray incident on the pole of the spherical mirror. This is our rule 4. Now, after these rules for drawing the ray diagrams, now we will see how to draw these ray diagrams here. Okay, and before that, very important thing, when it forms the image is after reflection, if the light rays meet at a point, then only the image is formed here. Okay, now we will see the ray diagrams formed by a mirror, spherical mirror called concave mirror, that is. Okay, now we are taking the object which is a far distance object we are taking, of which we assume that is coming from infinite, that is. Okay, so means if the object is placed at infinite, now we are taking. As the object is at infinite, now we are taking the light rays which are coming from the object as a parallel beam of light rays we have to assume. Okay, now we are taking a light ray which is coming from infinite, a parallel light ray. Here, to draw these ray diagrams, we can take any of the two light rays which are following the rules for drawing the ray diagrams. So that here I am taking the first rule. According to that rule 1, the light ray which is coming parallel to the principal axis, according to the rule 1, now the light ray after reflection, it passes through principal focus, like this. Okay, now the second light ray, here you can take any of the following the remaining rules here. Okay, so that, but the problem is the object is at infinite, means whatever the light ray you are taking, it has to be parallel. That's why here we are taking the light ray which is passing through the focus, or which is passing through the center of curvature here. If the light ray passes through center of curvature, then after reflection, the light ray comes back in the same path, or retrace back in the same path here. Then this is our first reflected ray and this is our second reflected ray, and both the light rays are meeting exactly at the principal focus. Okay, which means that the image position is at principal focus. Okay, and if you see the image characteristics here, image characteristics, as the light rays are really meeting at a point, the image formed here is a real image, that is a real image. And now as the light rays here, they are meeting exactly at the focus, principal focus, then the position of the image is formed on principal focus. Okay, and another important one, if you see, as the light rays we are taking above the principal axis which are coming from the object, but the reflected light ray is going below the principal axis, which tells that the image formed is a inverted image, that is an inverted image. And remember, all real images actually they form inverted only. Okay, so this is an inverted image. And if you observe the size of the object here, the size of the image is like a point, which means that is of a highly diminished image we are getting. Okay, it is forming a highly diminished image. These are the image characteristics formed by the first case, when the object is at infinite distance. As the object at infinite distance, now we are taking all the light rays are going parallel to each other, that is. Okay, so the image formed is a real image. Image is formed on the principal focus and it is an inverted image and it is of a highly diminished image we are getting. Now we will see the second position here. See, if you observe here, Now slowly we are moving the object closer to the mirror there. As in the first case, as we see, the object is at infinite. Now we are coming a bit closer to the mirror here, of which our next position is object is placed in between the infinite and center of curvature. Okay, object position is in between, object placed between infinite and center of curvature C, that is. Okay, as the object is in between infinite and center of curvature, we can have the length of the object here. Here we are not taking that as a parallel beam light rays here. Okay, now we are taking two light rays, of which following first one the rule 1, of which from the object now we are taking a light ray which incident on the spherical mirror. After reflection, the light ray passes through the focus like this. Okay, and the next light ray, of which now the light ray is passing through the focus following the rule 2. Okay, after reflection, now the light rays are passing parallel to the principal axis. Okay, then both the reflected light rays, this is our first reflected ray and this is our second reflected ray. Both the reflected light rays are meeting at a point, and you already see that that point is nothing but in between C and F. Not only that, if you see the size of the object is more, whereas the size of object is less. We call these type of images as diminished images, that is. Okay, that's why if you see the image characteristics, again both the reflected light rays are really meeting at a point. That's why here it is called as a real image. This is called as a real image. And not only that, as the size is less, okay, and not only that, it is forming in between F and C here, which is before the mirror it is forming. So the image is formed between F and C, that is. Okay, and if you see the size, that size actually it is of diminish in size. This is of diminish in size, diminish, which is less in size than object. And another important thing is, again, as it is a real image, always it is forming an inverted image. This is an inverted image. Okay, inverted means we are taking object above the principal axis, but the image we are getting is below the principal axis, upside down. That only we call that as inverted image, that is. Okay, so these are the image characteristics if you are taking the object which is placed in between infinite and center of curvature. Now we will see the next position here, of which previous one is as the object is in place between infinite and C, and the next position as we are coming closer to the mirror, our next position is exactly on C we are taking it. Okay, means object is placed on the center of curvature. Okay, as the object is placed on the center of curvature, again now we are taking the object, the light rays which are starting from the object when incident here following the rule 1, passing parallel to the principal axis. After reflection, the light ray passes through the principal focus. And the second one, now we are taking the second light ray following rule 2. As the light ray passes through the principal focus, after reflection, the light ray is passing parallel to the principal axis, so that both the light rays are meeting exactly again at the center of curvature line here. Okay, exactly on the center of curvature point here. So which means in case of if the object is placed at center of curvature, the image is also forming at center of curvature here. So, and again as both the two reflected light rays are really meeting at a point, again this is also a real image. And not only forming a real image, as it is forming below the principal axis, it is an inverted image also. It is an inverted image. Okay, now if you see the size, in both cases the size remains same. So that's why in case of this position, the object size and image size both are same size as object. And the position, if you see, as the object is at center of curvature, image is also formed at center of curvature. So image is formed on center of curvature, that is. Okay, these are the image characteristics if you place the object on the center of curvature. Okay, which forms a real image, inverted image, same size as object, and image is formed on the center of curvature, that is. Okay. When come to the next case, if you are coming much closer than center of curvature, our next position is object placed in between C and F, that is, which means here we are taking the object in between C and F point. Now we are taking, again following the rule 1 light ray there, the light ray which incident on the spherical mirror, concave mirror, after reflection passes through focus, whereas the second light ray which is passing through the principal focus, after reflection the light ray is passing parallel to the principal axis, that is. And if you observe here, both the light rays are meeting at a point. These two real light rays, reflected light rays really meeting at a point. Okay, that point only we call that as image position. As they are meeting really here, the image formed is also a real image. And we already know that, we already seen that here, object is taken above the principal axis and image it is forming below the principal axis. That's why it is an inverted image. Okay, and if you observe the position of the object here, it is forming beyond C. Means in between center of curvature and infinite, that is. Okay, that is formed between center of curvature and infinite, that is. Okay, and now you'll see the size. If you observe here, the size of the object to the size of the image size is bigger when compared to the object size here. So that's why here the image formed, we call that as enlarged image. The image formed is an enlarged image, that is. These are the image characteristics if you are placing the object in between C and F, that is. Okay, which is forming a real image, inverted image formed between C and infinite, and enlarged image, that is. Now we will see the next position, which is the fifth position here, where the object is placed, now further coming closer, which is previous one we are taking in between C and F, now we are taking on the principal focus here. So if object is placed on the principal focus, following again the rule 1 of which the light ray passes parallel to the principal axis, after reflection the light ray passes through principal focus, that is. And again the second light ray, this time we are taking following the rule 4, so that the light ray were incident on the pole of the spherical mirror, after reflection making angle of incidence is equal to angle of reflection here, and the light ray is passing here. But if you observe here, the light rays are not meeting at any point. They are going like a parallel beam of light rays here. As they are going like a parallel beam of light rays, here the image is taken as forming at infinite here. The image is formed at infinite, that is. So again we are taking the image characteristics. Here the light rays, as they are going to meet at infinite, now we are taking that as considered as real image. Okay, and as we are taking the object, the light rays are above the principal axis we are taking, but the image which is forming below the principal axis. That's why here this is again an inverted image. And not only that, as the light rays are meeting at infinite here, the image we are assuming that is formed at infinite, that is. So image is formed at infinite. Remember how we can conclude that is infinite is, as the light rays are going parallel to each other after reflection, that's why we can say the image is going to form at infinite, that is. Okay, and here again if you are taking the size as they are meeting at infinite, then the image size we are taking that as highly enlarged image, that is bigger in size. Okay, it is a highly enlarged image is forming. Remember this position actually we use that even in case of some of the telescopes also. Okay, so that here the image characteristics, if object is placed at the focus, is that it is forming a real image, it is formed in inverted image, and it is formed at infinite, and the light rays are going parallel there. That's why here it is taken as the image formed is a highly enlarged image, that is. Okay, now come to the second case. If object placed between F and P here. Here this is a very rare and special case we will observe in this concave mirror here. Concave mirror, most of the cases it forms always a real and inverted image, that is. But now here is a special case where even concave mirror also forms a virtual image, even though it is having a real focus. Okay, now we will see how it is forming that one. Now if you are taking the object very much closer to the mirror here, which is in between the focus and pole, then according to the rule 3, now we are taking a light ray which is passing center of curvature here, which means I am taking the light ray appears to be passing through center of curvature. Then after reflection, the light ray retraces back in the same path and again it is passing through the center of curvature, that is. And the second one, now we are taking the light ray which is incident on the pole. After reflection, according to that rule 4, angle of incidence is equal to angle of reflection, that is I is equal to R. Then if you observe these two reflected light rays, after reflection they are going like a diverging beam of light rays here. They are going to be like a diverging beam of light rays. As they are going like a diverging beam of light rays, both the light rays appears to meet at a point which is behind the mirror, that is of behind the mirror. So that's why here the image formed, as it is not really meeting at a point, we are assuming that as a virtual image, that is. So if you take the image characteristics, the image formed here is a virtual image, and we know that all virtual images are erect. Erect means upright images, that is. This is an erect image. Okay? Erect image means if you are taking the object is above the principal axis. If you see the image is also forming above the principal axis only. So these type of images we call that as upright image. There is no upside down. This is upright image, that is. Okay? Which is called the erect image. Okay? Next one, here if you observe, another important thing is these light rays actually they are forming behind the mirror, that is. So that's why image formed here, it is behind the mirror. This is behind the mirror. And the size, if you see, size of object is small whereas size of image is bigger. So which means here we are getting a highly magnified image. This is a highly magnified image. Okay, so these are the image characteristics formed by the last one, which is object placed between focus and pole. Okay, so see that image characteristics again, it is forming a virtual image, it is forming the erect image there. Erect image means upright image, and it is forming behind the mirror because these lines are not really meeting at the same point, the same side here. They appears to meet behind the mirror. So that's why here I am taking the image position is behind the mirror. And not only that, the size of the object, if you compare with the size of image is more and size of object is less. That's why it is forming a highly magnified image. These are the 6 positions we have in case of this concave mirror. And if you observe in all these 6 ray diagrams here, okay, now the object is placed at infinite from starting. Now we are taking the last position, which is the close position to the mirror here, which is in between F and P. If you observe all the images there, gradually the size of the image is increasing as the object is coming closer towards this spherical mirror. And not only that, here if you observe the image distance gradually increases if you are taking the object from infinite to a point very near to the mirror, then the image distance is increasing, which means that if the object is coming closer towards a spherical mirror like a concave mirror, the image is moving away from the concave mirror. Now we will see all those ray diagrams which we completed for the case of concave mirror. Now we will make a table for that, which is very, very important for our academics as well as for any competitive exam also. Okay. Now so that here actually we have seen total 6 positions of the object, means object position we are taking. Okay. Total 6 positions we have. First position, object is at infinite. Second position, object is in between infinite and C. Third position, object is at C. And fourth position, object in between C and F. And fifth one, object is taken at F. And sixth one, object is in between F and O or P, that is, which is the pole. Okay. Now for these object positions, now we got the image positions. If you remind that at infinite, if you place the object is formed exactly on the principal focus, that is, which is F. Whereas if you place the object, if it is coming closer, then the image moves to the next position here, which is in between F and C, that is. Okay. Now the third position, when object is at center of curvature, then image is also formed exactly on the center of curvature here. And if the object is in between C and F, then image is formed in between C and infinite, that is. Okay. And the next position, when object is at F, now the image is formed exactly at infinite, that is. And when object is in between F and P, then image is formed, which is a special case, behind the mirror. So these are the image positions we got for the given object positions. And if you see the nature of the image characteristics, which is the nature, if you see, in the case of first one, we are having the image which is formed at focus is a real image. And not only that, all real or inverted image we have. And if the object is forming in between F and C, even that also we are having a real image and inverted image. At the center of curvature also, we got a real and inverted image. Between C and infinite also, real and inverted image, that is. Okay. And when the object is placed at infinite, where the light rays, reflector light rays are going parallel to each other, there also we are considering the image is formed as real and inverted, that is. Whereas the last case, special case, the image which is formed behind the mirror, that is forming a virtual image. And we know that all virtual images or upright images are also called as erect images, that is. Okay. That is about the nature of the image we got. And final last one about the image characteristics here. Okay, which is about the size. Which is about the size. If you are taking when object is at infinite, the size we are getting here, it is a highly diminished we got. We got a highly diminished image, and gradually the size of the image, if you observe there, gradually increases. Highly diminished becomes, second case, it becomes diminished when the object is in between infinite and C. And image is formed exactly on C, then we are getting here the same size. And after that, if you place the object much closer in between F and C, now the image here we are getting a enlarged image we are getting. After that enlarged image, if you place the object here, after that C and F, now we are taking images at F, then here we are getting a highly enlarged image. And last special case, here we are getting a highly magnified image. Highly magnified. Okay. So these are the total images formed by the concave mirror, that is, of which when object is placed at infinite, image is formed at principal focus, so that the nature of the image we are getting is real and inverted, and it is of highly diminished image that is forming. Okay. And if you are taking the object is in between infinite and C, then image is formed between F and C, and the nature is real and inverted, and here it is formed is a inverted image, that is. And here if you are taking for the case of object is at C, image is also formed at C, its nature is real and inverted, and the size if you are taking same size. Okay. Like that's the next case in between C and F, image is formed between C and infinite, and it is forming a real image, and here we are getting a enlarged image. And after that, if object is placed at focus, then image is formed at infinite, and here we are getting again a real and inverted, and it is of highly enlarged image. And last one, which is the special case, if the object is placed in between F and P, then image is formed behind the mirror, and it is a virtual and erect image, that is, and it is of highly magnified image we are getting. If you observe that here, as the object is coming closer and closer towards the mirror, the image is moving away from the mirror, like F and C, C and infinite, that is. And object positions coming closer and closer, infinite and C and F and P, that is. And not only that one, even if you see the size there, the size at first it is highly diminished like a point. After that we are having diminution size less than the object size. Next one is the same size as object. Next one is enlarged, means the size of the image is more than the size of the object. And the next one is a highly enlarged, and last one we are having a highly magnified image we are getting in the last case. This is the nature of the images formed by the concave mirror when object is placed before the mirror, and so that if you are moving the object near towards the concave mirror, that is. Now, just like the concave mirror, now we will see the ray diagrams formed by this convex mirror. But remember, concave mirror is having a real focus so that it can form the real image other than the special case. But convex mirror is having a virtual focus because it is having a diverging nature. So that's why here the image formed by these convex mirrors are virtual images because their focus is a virtual focus, that is. Okay. Now, just like the previous positions, if you take for the case of convex mirror, object is at infinite distance here. If you are taking object at infinite distance, as we know that the object, the light rays are coming like a parallel beam here. Now, if you are taking, following the rule 1, if the light ray is coming parallel to the principal axis, after reflection, the light ray appears to be passing through focus like this. Now, second light ray if you are taking, just like the previous one, if you are taking the light ray passing through center of curvature which is incident at the pole, after reflection, now the light ray with angle of incidence equal to angle of reflection, now the light ray is as angle of incidence equal to 0, angle of reflection also becomes 0. Now, it is retracing back in the same path. This is our first reflected ray and this is our second reflected ray. These two light rays will never meet at a point because they are diverging here. So, that is why these two light rays are appears to be meeting at the point F here, which is our principal focus. So, that is why here the image is formed is a virtual image, that is, here it is forming a virtual image. And not only that, that virtual image actually it is forming behind the mirror, and all virtual are erect images, that is. That is why even this also an erect image. And after that, if you are taking the position of the image here, that is formed behind the mirror, that is. And it is forming behind the mirror means if you size the size, if you see the size of the image formed here, it is of highly diminished size, that is of highly diminished. Okay. Now, these are the image characteristics formed by our convex mirror. When object is placed at infinite, of which appears to be like a parallel beam here, after reflection it is forming the image, a virtual image, erect image behind the mirror which is of highly diminished. Okay. And when you come to the next case here, at any position you took other than the infinite, which means any finite distance you can take from between infinite up to that point pole here, anywhere you see, the ray diagram remains the same, means the image formed characteristics are same for this. So, that is why you need not to take the remaining 5 cases in case of this convex mirror, only one diagram is enough for that. So, means any finite distance you can take here, any finite distance. If you are taking any finite distance here, let us suppose if the object is placed at here, okay, other than infinite, in between infinite and pole here. Now, following rule 1, the light ray which incident coming parallel to the principal axis, if it incident on the convex mirror, now the light rays appears to be passing through focus like this because it is a virtual focus. And the second one, if you take this light ray which incident on the pole, now the light ray after reflection it is passing, making angle of incidence equal to angle of reflection, that is. Now, this is our first incident, first reflected ray, this is our second reflected ray, and both the light rays are appears to meet at a point at here like this. Now, this is the formation of image and this is our object. Okay. Now, if you observe here, as the image is forming again behind the mirror and not a real one, so that is why again here the image characteristics becomes, this is a virtual image. And not only that, if you are taking object above the principal axis, image is also above the principal axis, that is why this is an erect image also. Okay. And not only that, if you see the size of the object is bigger, whereas the size of the image is smaller. So, that is why these are called diminished images. Again, this is a diminished image. Okay. And if you are taking the position of the image is actually it is behind the mirror, that is. So, that is why the position of the image is behind the mirror. See, not only for this, any case if you are taking other than infinite, always the image characteristics formed by the convex mirror is the same like this. Okay, of which it is forming a virtual image, erect image, diminished image and behind the mirror, that is. Okay. So, these are the two ray diagrams we are having for the case of convex mirror, of which both are having the same nature of virtual and virtual, erect and erect. Those are of diminished in sizes and both are forming behind the mirror. This is about the ray diagrams of convex mirror. Now, we will see finally the spherical mirrors about their nature of reflection here. Okay. We already seen the ray diagrams image formed by those convex and concave mirrors here. In final, we will see its nature of the image formation here. Okay. If you observe in that concave mirror, whenever the light rays incident on a concave mirror, it is having a nature such a way that it is trying to converge all the light rays to a point here, like this. Means concave nature is a converging nature. As it is having a converging nature, it is having a real focus. As it is having a real focus, it is forming a real image. And if you observe that concave mirror forms all types of images here, so that it can form a diminished image, highly diminished image, same size image, and highly enlarged image, along with that virtual or magnified image also. Whereas if you come to the case of convex mirror is different. So that if you observe the concave mirror here, after reflection from this convex mirror, now the light rays are diverging away from each other, like this. So this is having a diverging nature, whereas concave mirror, it is having a converging nature. Okay, and this is having diverging nature. So whenever if you want to focus the light rays to a point, we always prefer a concave mirror, whereas if you want to diverge the light rays, here we prefer a convex mirror, of which we use that even in case of a torchlight also the same thing, of which if you want to diverge the light rays, we prefer the convex mirror, and here in case of this concave mirror, we use a converging beam here. Okay. As the convex nature, it is having a diverging nature. This mirror actually we will see at the parking places here. One of the important applications of the convex mirror, so that it can deviate the light rays in all the directions here, so that we will have a rear view is present. So that's why here this convex mirror is also called as rear view mirror, that is. Okay, that is about the nature of the convex mirror and a concave mirror. Okay.